All right. Welcome to today's Northern Grapes Project webinar. My name is Alex Koeberle. I'm a program assistant for the Northern Grapes Project. Today's webinar is Tales from the NE1020 Coordinated Variety Trials with Tim Martinson and a panel of Northern Grapes Project team leaders. Tim Martinson is a Senior Extension Associate for the Horticulture section at Cornell University. Tim works in viticultural research and extension at the New York State Agricultural Experiment Station and has been the project leader for the Northern Grapes Project for the past 5 years. As project leader, Tim has coordinated all project activities and has conducted research on crop load management and training systems in commercial vineyards in northern New York. Remember that as a participant in the webinar, we ask that you keep microphones muted if you have them. If you are having any technical difficulties, please type a note in the chat bar over to the right side of your screen and I'll do what I can to help you. If you have questions, please type them in the chat bar as well. We'll have a question and answer session after Tim's presentation and throughout the panelist discussion, so feel free to type in your questions anytime if you have them. The 5-year Northern Grapes Project just concluded this August, but we will continue with Northern Grapes newsletters and a monthly webinar series thanks to these generous industry donations. After Tim's presentation, we'll open up a discussion with participants and Northern Grape Project team leaders from across different regions of the U.S. Now I'd like to turn it over to Tim Martinson for today's presentation.
Okay, thank you, Alex. And thank all of you for joining us here. So what I'd like to do is I'd like to spend about a half an hour talking about some results from these red dots that you see on the screen. These are sites at which we have had since 2007 or 2008 something called the NE1020 Coordinated Variety Trials. Again, they were set up in 2007. So what I want to report on today is how we looked at vine performance at 11 locations here over 5 years. So in my talk today, I'm going to outline, first of all, what we found in terms of yield and quality of the grapes. I'm going to talk about phenology and how that varied over the different sites. We're going to talk a little bit about vine balance metrics and then the impact of winter injury. As you know, we had a couple weather events during the last 5 years that really had a big impact on winter injury in several sites. So, thanks to Google Earth, we can go to the different sites and see the plots. So here's 6 of the 11 plots in different locations: Brookings, South Dakota, Geneva, Ames, Iowa, Traverse City, and 2 that are right across from each other: Willsboro, New York, which is on the west side of Lake Champlain, and then the one at Burlington, New York, that Terry Bradshaw manages on the east side. So they're just a few miles apart. So these are the coordinated variety trials, and basically they are there to answer the question, how does the growing environment in these different locations affect the yield and quality of these varieties. So, so we collected information on vine performance and the climate and evaluated yield and quality and compared those with climate indices and have data from numerous sites per variety. Why is this important? Well, as you can see from this figure of the plant hardiness zones, all of these varieties that I was going to talk about, they were developed in southern Minnesota or western Wisconsin, where there's about 2,500 growing degree days. So in other words, they're developed in a particular environment. But across the different regions, then we have a lot of different environments. If you go up to North Dakota, the 30-year average growing degree days there are about 1,800. If you go down to the middle of Iowa, there's a lot more heat units. If you go to the northeastern U.S., near Lake Champlain in Lake Ontario, we tend to have 2,000, 2,100 growing degree days. And the other thing that's different about these sites is the difference in what we call a continental versus a maritime climate. Many of the sites in Michigan, New York, Vermont have some degree of water, large bodies of water that moderate the climates. And this is particularly important in the springtime when we don't, the temperature tends to ramp up slowly, so there's a slower transition between seasons than there would be in the Midwest, where it's a continental climate, and the changes between the dormant season, the cold weather, and the hot weather tend to be more abrupt, and it warms up faster. So here's just an illustration of some variation in monthly degree day accumulations in Geneva, New York, which I think of as the standard because, of course, I live here. Ames, Iowa, you can see that starting in May, the temperatures are significantly higher and there's more accumulation of growing degree days through September. If you look at Fargo, North Dakota, the green bars, on the other hand, you can see that there's things get started later. And really, during the middle of the summer, June, July, August, then pretty similar temperature profile to upstate New York here. But then as you go to the shoulders of the seasons, May and September, that falls off rapidly. So that's a much shorter growing season than we have here in New York or in Iowa. So this group has been meeting annually, and it doesn't just comprise northern grape site. There's a lot of other sites where we have the coordinated variety trials. But we got together and we put together a data collection protocol for these sites. And here's just an example of some of the specific things that we said that we would collect. So we have the specific data needed on pruning weight, cordon length, nodes, and so forth, a procedure for collecting it, and units. Now this was aspirational, and we didn't really live up to that aspiration to collect all this data, but we collected a lot of it. So I'm focusing on the NE in the Northern Grapes Project on 5 varieties: Frontenac, Gris, Marquette, St. Croix, and La Crescent. And that's because these existing trials, many of the places had pre-existing plantings of this when we started the Northern Grapes Project. So those are the varieties I'm going to focus on today. So the question comes up, well, why is it good to have variety trials in different sites? I guess the answer to that question in a practical sense is the real question is, can you grow a specific variety profitably in these different environments? So among the important questions are, how often can we expect winter injury? We have enough heat there to ripen them, and what is the fruit composition is typical for the region, and what kinds of wines can you make out of it? I can't answer all those questions with this data, but I do have some personal benchmarks that I feel are worthy of saying whether a variety is suitable for an area or not. And one of them has to do with yield. Even with high grape prices and the smaller vineyard blocks, I tend to think of 4 tons per acre of fruit over a 5-year average as sort of a cutoff between profitability and marginal profitability. So that's a benchmark I use. We want to see a low frequency of winter injury. The bud burst and spring frost, don't want those to happen too often. And then we want to make sure that over a climate variability, that the acid, sugar, and pH are in acceptable ranges. Alex, if you could put in the link to this, all the yield data year by year is way too much to present in a webinar, so I thought I would put this document together and just put the entire summary for all the years of the project and all the sites here. So what I'm going to do then is not show you the yearly data, but you can download that and follow it by yourself and see the variability in the different sites for yourself. And I'm going to go through briefly here just the overall averages.
Yes, so all the participants, I just included the link to Tim's data sheet that he mentioned. It's in the chat bar.
Yeah, you can find it right in the chat bar. So in this table, I did put two measures of yields. I put down pounds per vine and tons per acre. And the reason I did that is because we have a lot of variability in planting density. So in a sense, it might be misleading to compare tons per acre since the planting density is so different. It might be better to have the yield per unit of row length. But it's hard for me to say that if you have 545 vines per acre, but still at 8-foot row spacing, that the 10-foot rows versus the 9-foot rows are going to make any huge difference. So that's why I put down both measures. So briefly, I want to go through this, and for each one of them, I have the summary table of the 5-year, 2 to 5 year to 7-year summary, and then a range that we found at the different sites. So for Frontenac, our range was 5.5 to 28 pounds per vine, 1.7 to 8.6 tons per acre, and a twofold range of titratable acidity. So if I look back at those metrics, I can say that the sites that are bounded by that red box are pretty close to the metrics that I wanted in terms of yield. Again, around or above 10 pounds per vine, and you can see that even with that, there's a lot of variability in the tons per acre because of differences in vine density. Okay, so that's fourfold difference in pounds per vine, fourfold difference in tons per acre among the sites, and a twofold difference in titratable acidity. So I'm going to go through rather rapidly because I have lots of these tables. Here's Frontenac Gris, and that's pretty much the same story, fewer blocks, but again, a fourfold difference in yield, twofold difference in titratable acidity at harvest over all these growing seasons. With La Crescent, we did see a few more years where there was actually no crop, and so I put that in the comment section there. But again, 4.7 to 18 pounds or to 19 pounds per vine, 1.4 to 6.6 tons per acre. And the only thing that might be screwy on this is the Massachusetts titratable acidity, 4.5 grams. That doesn't look right, and maybe Sonia will comment on that a little later. Okay, so again, about 2/3 of the sites sort of came close or met the yield targets that I'd set. Here's Marquette, and again, 3 to 19 pounds per acre. Not much variability in bricks, but again, 8 to 14 grams per liter of titratable acidity. So we'll see in a little bit which ones are on the high end of that range. St. Croix is a little bit of a different variety, but again, we saw this 4 to 24 pounds per vine, a 6-fold difference in tons per acre. This tends to have lower bricks at maturity because of its labrusca heritage. So there's a range of 14 to 23 bricks, and then twofold range of titratable acidity. And then again, this has a tendency to have lower titratable acidity. Okay, so I want to switch now to phenology, because phenology is something that you might expect would change. So what I've done in these graphs is I've just have these bars representing the range of values over all varieties and all years at the site, at each site. So, so the overall average for bud burst date was May 8th over all sites and over all years. And you can see that May 20, the North Dakota, which is the bar in the middle, that had a later bud burst around May 26th. So that was sort of an outlier. And then there's a number of these that had bud burst in April 1st. Then tended to be the southern sites, and the warmer sites in 2012 in Iowa, Massachusetts, and Michigan that really had extremely early bud break, unusually early in that particular year. Okay, if we look at the degree days at bud burst, I don't think degree days are a really good measurement of bud burst and when that happens. But here we see a couple of differences that are regional that I tended to pick out. So they tended to separate into the water moderated sites in spring, which tend to warm up a little slower, and then the continental sites, which tend to have higher temperatures early in the growing season, and therefore, by the time you reach bud burst, tend to see higher degree day accumulations there. So harvest date, I was kind of surprised that that this is a fairly narrow range. Again, North Dakota, with the median value at October 7th, appears to be a little later than the rest of them. And again, so the majority of them, it's in this sort of 10-day window between September 10th, September 22nd, which is the grand mean. And again, we have some outliers that probably happened in 2012 with harvest as early as middle of August. But then when we look at the accumulated growing degree days at harvest, we do see a big trend there where, again, Connecticut, Iowa, Massachusetts sites that tend to be a little more southerly have a lot higher growing degree days than some of these water moderated sites, or the sites like South Dakota and North Dakota, Michigan, New York, Vermont. So so that's the difference that kind of jumped out of the data. Soluble sarvis at harvest. This is across all the different varieties, so I'm sorry, but I'm afraid this is just sort of all over the place. And the other thing about the soluble solids is that those are very sensitive to the differences in cropping level. So this is probably not a very good overall metric from 40,000 feet to show the variation among the sites in those varieties. On the other hand, titratable acidity, we see some trends there related to the sites. Again, Connecticut, Iowa, Massachusetts, and the Michigan sites tended to have lower titratable acidity. And the ones in the Dakotas and the New England area, New York at Geneva, Willsboro, Vermont, tended to have higher titratable acidities at harvest. So that really ties in with the higher growing degree days in some of those sites. That those the higher heat units made the varieties end up with lower acidity at harvest. Okay, so the third question that our data was sort of designed to say is, well, at these sites, are the vines in balance? And so the metrics we use for balanced vines are what's the pruning weight. The pruning weight is an indicator of how big the vines are. What's our yield? And our yield per foot of canopy, which is a kind of a good metric of the yield per unit area. That's independent of row width spacing and vine spacing. And then the third one is the Rivaz index, which tends to be a little fuzzy, but that's the yield to pruning weight ratio. Okay, so I'm going to go through these metrics, and what I've done here is I've taken all of the data from individual years and sites and put it into a distribution. So each one of those graphs shows the range of pruning weights that we saw across sites and varieties. So if you look at the overall mean of the pruning weights here, you can see that the median value, so that's 50% of the site and year combinations, is about at 1.2 pounds per vine. So that means that half of the sites and years had pruning weights less than 1.2, and half of them had more than 1.2. If we look at optimum metrics, optimum metrics, some published figures indicate that 0.35 pounds pruning weight per foot of canopy is optimum. If we looked at 6-foot vine spacing, that would be equivalent to about a little bit more than 2 pounds per vine. If we looked at 8-foot vine spacing, that'd be a little bit more than 3 pounds per vine. So we can say that on average that maybe the vines in all these trials were a little bit on the small side size, and that there's enough space and place for them to really have bigger vines at many of the sites. So yield per foot of canopy. So I just put in a blue line there that would be equivalent to, if you had 9-foot rows, 1.7 pounds of crop per foot of canopy would equal 4 tons per acre. And you can see about half the vines have less than that, half the vines have more than that, some have a lot more than that per foot of canopy. So that just ties into the variability in yield that we saw in the earlier slides. So the interesting part here about the Rivaz index is that that's the ratio of yield to pruning weight. So you take the yield in pounds and divide it by pruning weight in pounds, we come up with a ratio. And public ranges, publicized data indicates an optimal range of 5 to 10 for this ratio. If you're under that, then your vines are undercropped. If you're over that, your vines are overcropped. Frankly, I don't know what it means to have these very, very high ratios of 45. So that means a lot of crop compared to the vine growth. So those vines are probably overcropped, and the ones that are down at the lower end are definitely undercropped. So overall, just to summarize that, I'd have to say that in these NE1020 plots over the 5 years, that in many sites, at least half the sites, the vine size was pretty small, as indicated by the pruning weights. The yield per foot of canopy was variable, and the Rivaz index was low for some and high for others. So I want to close, I'm getting close to closing here, and talk about winter injury metrics. I was surprised as I went through this data that that wasn't very clear from the data we collected. Not everybody collected bud counts and so forth, but where I did have them, this sort of jumped out at me, and that's a metric that I call shoots per retained node. So if you leave 40 buds and get 40 shoots, that's where that blue line goes across. So that's 1 shoot per retained node. And you can see with some of these sites, in terms of yield, including the one of the kinetic sites, North Dakota and South Dakota, they come out on average well below the 1 shoot per node range, whereas some of the others, Connecticut, Iowa, New York, Vermont, come out well above that shoot per retained node. Okay, so that's what you see on the left is if we look at tons per acre versus shoot per node, you know, the more shoots per node you have, the higher yield you have. If you add to that in the middle there, the clusters per shoot or clusters per node, that improves the prediction of the yield. And if you add in cluster weights to that, then that is indeed a much better measure of yield predictor for the site. So that's the crop per node. Also, we call that bud fruitfulness. And it certainly makes a difference. And I just wanted to show you these slides from our plots in Clayton, New York, where we had high cordon versus VSP. And in over 2 years at this site, you know, certainly we had a big difference in cluster size, also more clusters on the high cordon than the VSP. So this translated into a huge difference in yield without having a huge difference in things like titratable acidity. So in other words, we had a kind of double a crop on the high cordon because of the larger clusters and more clusters per vine, i.e. higher bud fruitfulness with the same number of buds. But that didn't really impact the maturity in terms of the acid levels, although it did impact bricks somewhat. Okay, that's where I'm going to close here. Just to summarize, one of the good news from this is that economic yields are definitely achievable. We saw this at the Vermont, the Willsboro site, Michigan, and at our site in Geneva, where we just did 2 varieties. But in many of the sites, the vine size is small, way less than 35.3 pounds pruning weight. More heat units translated into lower titratable acidity overall, and it appears that in northeastern sites with our cooler and more maritime climate, that we don't get as much of a drop in titratable acidity as you would get, say, in Iowa or even the Dakotas in some cases. So the only winter injury metric that I used here was looking at the shoots per retained node, and that being, you know, a good predictor of the final yield. And finally, you know, our data was really skewed because following the polar vortex, if there wasn't any crop, some of the sites people did not collect yield data, so we did not report that. So that probably skewed some of those yield averages and so forth because we didn't take into account those years in which they didn't have any crop. So finally, you know, I think you know, we are all academics, so our management. So I'm not going to pretend that all these blocks that we had were managed very professionally. So I think it is possible with good management to improve the vine size. And then it is possible in areas where you do get some winter injury to retain more buds as a hedge to winter and spring injury and then adjust them. So that would be, in my mind, the way to higher yields and more sustainable vineyards. So I'm going to stop right there and thank you for your attention, and then we'll turn it over to everybody else. And it looks like we're right on time here at 12:30.
Yes, perfect. Thank you, Tim. I know you had a lot of data to sift through, so we really appreciate the time you spent for your presentation. Tim, I think I'll leave you as presenter, if you want. Do you mind scrolling to your next slide? I think you had Do you have another slide?
Oh yes, I'm
There
sorry.
we go.
I
Okay.
wanted to acknowledge all the team members. Yeah, thank you.
So I don't see any questions yet. Tim, should I just turn it over to the team members, or do you want to?
I think that'd be good. Yes.
Okay, great. So I'll just go through alphabetically. So first, Harleen Hatterman Valenti from North Dakota State University. Harleen, if you'd like to unmute your microphone. Each panelist, you can have a few minutes to just respond to Tim's observations, and if you have anything to add or comment that's specific to your variety trials, feel free to participate.
Okay, Alex, is this coming through okay?
Yes, I can hear you fine.
Okay, wonderful. Well, I really appreciate all the work Tim has done to go and put this together, and it really brings out some enlightening aspects of production of these cold hardy grapes. I think everyone saw how North Dakota was kind of lagging behind in a lot of the yields, and I looked at the data and I see how, 2016, for the years that we have, 2016 seems to be a wonderful year in comparison to the previous 4. And so I went and I put some weather data together, and I was looking at the fluctuations of our min and max temperatures. And sure enough, when I was looking at the winter of 2015/16, as far as those cold temperatures that we had in October, November, never dipped much below the normal, our normal temperatures. But if I looked in the previous 4 years, I had a lot of temperatures early in that fall, and especially in 2014, I had a time, I want to look at the exact date, it was September 8th that we got down to freezing, and so our average low temperature, or we were down to 0 degrees Fahrenheit, I'm sorry. Our average low temperature at that date generally is about 45 to 50. So, those kind of things I think really are part of what we're trying to go and resolve here in North Dakota, is how to prepare these vines earlier in the fall so that we can minimize our winter injury and maximize our production.
Okay, thank you.
Thank you, Harleen. Yeah, next, hello, Diana, are you there? Hello, Diana.
Hey, can you hear?
Yes, I can hear you fine.
Okay. Yep, sorry about that. Yeah, so I'm here also with Kenny McCabe, who's the vineyard technician, so I might have him chime in if I miss something up. But so everything, I mean, seemed, I don't know, like for this year or for this past harvest, I don't think our numbers were up. So this past in 2016, so they were up a little bit, which was good. We harvested a couple weeks early than normal. Bricks were slightly lower, but for the most part, I mean, they seemed pretty decent and average with what we had reported for the, about the 5-year average. As far as minus in 2012, I know some of the dates that Tim reported, that 2012, that was a really drought year for us, and then followed by a really hard freeze. So there were some issues in 2012 and 2013. But for the most part, we've had a nice, I mean, last year I would say was a nice, successful harvest for most of the cultivars.
We did also have some hail damage about the second week of July, so that might have lowered things slightly, but it wasn't too big of a deal.
Yeah, well, all those weather events are things that were not really quite captured on the data sets that I got. So that's one of the reasons why I wanted to, you guys to respond about things that happened over the course of your trial there. So, so yes, the drought year is one. The polar vortex is another one at different sites and so forth. And I don't know, even 5 years of data, that's not going to tell you sort of what the probability of these weather disasters are going forward.
Right. Too bad they can't predict when hail's going to come either. That would be awesome.
That's what crop insurance is for. If you can get it.
Great. Well, thank you, Diana. Next, we'll move on to Terry Bradshaw from University of Vermont. And Terry, I just unmuted your microphone.
Oh, here we go. I'll turn my volume down. It says I'm echoing. Everybody hear me fine?
Yes, you sound clear.
Right. Yeah, I've been making a few notes as we've been going through here. It seems like in Vermont, within this particular set of cultivars we're looking at in the Northern Grapes project, it's a little bit different from the cultivars we were looking at overall in the NE1020 project. So we had a handful of other cultivars that we did look at over the years, one that we continue to look at, that didn't make the grade, and there's a reason why they're not Northern grapes, or at least truly cold climate grapes. We had Traminette and Vignoles that were pulled out in I believe it was the end of 2011 growing season, that for various metrics just didn't make the cut between mostly cold related yield, which was a proxy of cold hardiness, and then as far as Vignoles was concerned, just extreme disease susceptibility. So that one left, and then Traminette Coron Noir has been another one that we kind of put in there as our other less cold hardy variety, and that's done fairly well except for in the winters of 13-14 and 14-15 when it was cold. And then we've had substantial, I guess you had a few vine deaths, but mostly arms that died out, cordons that died out, and just really low crop yield. So within the Minnesota cultivars, all of these are doing fine for us. Most years, everything has crossed that 4 ton per acre threshold. And the trick here, and Tim pointed this out, is that even though we are amongst the states that have had the plantings that have had the highest yield, and I'm sure that's partially because of the moderating influence of the lake being pretty close by, we've also got the highest TA, and anybody who works with these grapes outside of St. Croix anyway knows that the titratable acidity can be a real problem as far as winemaking quality goes. And if correlation doesn't equal causation. So if you look at this and say, well, high yields mean I'm going to get high TA, not necessarily true. As Tim pointed out, in these northeastern states, we're also generally speaking cooler in the summer, even though we might not be as cold in the winter. And that might be, so Iowa, for example, had warmer temperatures during the growing season, particularly during ripening, that allowed that acid to come down. But also during the polar vortex, the folks who were west of New York were on the cold side of that vortex and really got hit hard, whereas by the time that vortex wrapped down through the south and came up to us on the east side of New York, and I don't know exactly where you want to pinpoint the center of the vortex being, we were actually fairly moderated, and I would have to look back at my weather records. Actually, I've got them somewhat handy here. Yeah, our absolute winter low during those couple years, and these are in Celsius, but I had a -26 in 2014, -24 in 2013, and those actually aren't that much different from most other years for us. So there was cold. I think 2014 was an extended cold. I mean, they just never, it wasn't just a few snaps, but it was really extended all winter. But we haven't seen a tremendous amount of cold damage on those particular cultivars. Something that's been highlighted amongst us as we're planning the next phases of both NE1020 and Northern Grape is to look a little bit deeper into the acclimation of these vines. You can't just say, you know, Frontenac is hardy to -30. There's books out there that will say such a thing, and I guess in theory they are 30 or 35. But it's how do they get there? That's the question, and that's something that I think a lot of us are interested in. We only had one event that I can think of, which was it was the winter going into 2013, November, December, sometime in December 2013, where we went from a pretty sustained warm spell to a pretty cold snap, you know, within a couple of days. It wasn't one of these that you hear about particularly in the continental areas of the country, where, you know, where you go from 65 to, you know, -10 in 24 hours. But those are the questions that have been coming up: is when does it get cold, and how did it get there? You know, what was the pattern leading into it? So that's something that I think we're more interested in looking at a little bit more deeply. The other thing I wanted to highlight, I think, with our planting, and I don't have slides necessarily to show from this, but we've put quite a few different publications out there around this. But one of the real nice things about these grape varieties, cultivars, compared to vinifera or even the more vinifera-like hybrids, is when you're bringing in that Riparia and even some of that Labrusca lineage, you're not just bringing in cold hardiness, you're bringing in resistance to the diseases that they co-evolved with here. So we've been finding, generally speaking, pretty good disease control with 4, maybe 5 fungicide applications on these cultivars. And that's a real benefit. We did find, this is one of the reasons why things came out, Courroux Noir had higher incidence of downy mildew. Vignole would get hammered with downy mildew with 4 or 5 fungicides. So you'd have to keep protection right through close to harvest on there. Whereas these other ones, you know, I'm usually done by July 4th, July 10th, something like that. Rarely have I put on. In fact, we've intentionally undersprayed our vineyard to tease out some of the differences. And it comes down to it: if you underspray to the point of not hitting those last critical infection periods, you're going to have downy mildew and or well, I should say you're going to have powdery mildew on virtually all your leaves. Won't necessarily be on the fruit if you protect it at the right time. But black rot in particular, we could keep that down to a pretty dull roar, again with 4 sprays, sometimes in a pretty wet year. And that's been a real benefit. So I think that's been a nice thing about these cultivars, and anybody who's moved from you know, vinifera planting to these, I think can appreciate, in the wet east, I think can appreciate that you know, nice factor that they have.
Yeah, I'm going to second what you had to say, Terry, because I think that's one of the areas where people can really improve their disease management and minimize their sprays. Sometimes I hear in the Midwest, and this come out in surveys too, well, weekly sprays, you know, 10 applications, 12 applications, and I really feel that, you know, even in warmer climates, that really the critical issue in the sprays for people is actually timing them correctly and starting early enough. So we found the same thing at the Willsboro trial, that we can get very good disease control with, you know, a 4 to 6 spray program there. The other thing I wanted to mention is this thing about the titratable acidity. So the only thing that I have found that we can do in our climate to really reduce titratable acidity, it's not a matter of reducing the crop, but it's a matter of getting more exposure to clusters so that they stay warm, so that they heat up. So if they are exposed to sunlight, then they will heat up and they will have, according to our trials, a couple grams lower titratable acidity than if they were shaded and in the middle of the canopy. So that's just the point I wanted to iterate. So thank you very much for your contribution, Terry, and appreciate your comments.
Hey, Tim.
Yes, Harleen?
I think that's a great comment about the TAs, but with the heat and everything. But there are cultivars that I feel do not respond to that. We've done a couple of leaf removal trials with Frontenac, and
Yeah.
we do not see that kind of response.
Yeah.
But we did see it with Marquette, so I think it's very cultivar specific.
Well, that's true, and I've done a lot of work, a lot more work with Marquette, so that's definitely true of Marquette, and I think Frontenac is pretty resistant to that. That's a good comment. Okay, who's next then?
Yes, thanks Harleen and Terry. Next we have Sonia Schloman from University of Massachusetts.
Can you hear me?
Yes, we can hear you.
All right. I don't have a great deal to add, just a couple of comments that I wrote down as we were talking. And one of the things that I was wanting to say, at least about the Massachusetts vines, we don't have a great deal of data that we contributed to this, just a couple of years fairly early on. So it may be more true for us than for some of the other sites, that the comment that, Tim, that you made about vine size being relatively small and sometimes the crop load being high on those vines, I think that that was quite true for us. And the vine size had a lot to do with the fact that they were relatively young. They had only recently been planted, so they weren't really fully up and mature vines, which they are now. And I think the data that we're going to be collecting going forward will be a little bit more representative of how the vines will do in our particular location. We also have a little bit more of a robust program to support all of this, which has been lacking up until now. So that explains some of our situation. You did mention the very low TA. I forget which variety it was on in the slides. But I think we are trending towards the low end on many of the varieties. And I have to say, honestly, that I think that's probably more of an equipment or apparatus error or unreliability issue. So I wouldn't put a lot of stock in those numbers for us in Massachusetts. But again, we've got a little bit better setup for all of that going forward. So I think we'll be getting some better data out there. And also, that sort of plays into the high yields, where for many of the years that we've had these vines in the ground, we've had not enough labor to really do all of the management practices that we should be doing. So we did have some pretty high yields. We were pushing these vines hard, not because we were trying to necessarily, but because we didn't do much in the way of shoot thinning and cluster thinning. So these vines were kind of cranking out all they could. And so that was a bit of a test for some of them, and some of them did all right anyway. Yeah. But I wouldn't necessarily recommend that to growers in their vineyards. And finally, I guess the last thing I just wanted to mention is that for us, and I'm not sure if this is true for other sites as well, but one of the things that's very noticeable is that the Marquette and the La Crescent vines for us are very early. The fruit ripens very early for us on those, and almost a little bit too early, because they're so much ahead of many of the other varieties that they caught us by surprise on occasion, and they kind of went over the hill on us before we were quite ready to do much with them. And so it's worth mentioning that for folks that want to grow them, because they have a lot of good things to offer, that you may be having to be kind of up and ready for harvest sooner than you expect to be with those two varieties, at least for us, and I'm not sure if that's been true for other people. So I guess that's all I wanted to say.
Thanks, Sonia. And so it sounds like what you're saying about those early years is that maybe you crop them a little bit too heavy in the early years before the vines have caught up to the vine size. Is that?
Yeah,
would that be accurate?
I think that would be fair to say.
Okay, great.
Thank you, Sonia.
Sure.
So I believe that's everyone we have for the afternoon session. Let me know if I'm missing anyone. And then to participants, feel free to ask questions. We have about 10 minutes left, so type your questions in the chat bar below and just make sure that your chat bar is set to everyone. We have a question from Mick. Was Sonia harvesting the crescent at 20 bricks?
I would say the data that we submitted was for a number of years ago, so I can't recall offhand right now, but I would be, I think it would be fair to say that we were in the 20s, low 20s probably, and La Crescent is certainly capable of going higher than that. I'm not sure if that answers your question. But.
Great, thank you. Yes, and just a reminder, make sure questions, just set your chat bar preference to send to everyone instead of private message. So I'll go through a couple questions we've had the past few minutes. First, Mike White has a comment. The many sprays we use here in Iowa have to do as much with rain as our heavy dews. For example, corn puts a lot of moisture into the Iowa air. Heavy dews throughout the summer and late summer create a high potential for disease.
Okay, Mike, I acknowledge that as a thing, but I also feel like sometimes that the newer growers, they don't put as much emphasis on really getting down to the day in terms of spray intervals early in the season. And my take on it is that if you do a great job early in the season, then by the time you get to the middle season, even if it's rainy and humid, and a possible exception to that would be downy mildew, because downy likes humid, wet weather, and that can rip through an area fast. That my feeling is that many of the people in the Midwest haven't gotten there in terms of figuring out a good, reliable spray program and making sure that their spray intervals were very tight when they needed to be, and then being able to back off a little later on in the season. So that's my take on it. But I could be wrong, and I'm sure it is very moist and warmer in Iowa. We do have quite a bit of corn here too in the Finger Lakes, so we do have a lot of dews and so forth. So, but
this is Terry here. Yeah, I thought this was interesting. I forget where I was speaking with someone. It might have been at the NE1020 meeting that we had back in November. But I was pretty amazed, and I looked a little bit into this at truly how much evapotranspiration causes the humidity in the major corn states. And I thought that was pretty interesting. So not only do you have to worry about herbicide drift, which is probably the biggest issue with growing next to to hundreds or thousands of acres of corn, but that that I was amazed to see how much moisture was pumped in. But I agree with you, Tim. The key to that 4 or 5 spray program is very well timed, using the proper materials. If you're relying strictly on sulfur or copper, you're not gonna cover all the bases on there. But if things are timed right and you take care of the initial inoculum from the early season infections, we've seen really good control of diseases even if we stop early on. The issues that we've seen is where we've stopped maybe a little too early in particularly wet years. So 2015 was very wet for us, and I wanted to actually draw out some data on these, and we wound up with powdery mildew on essentially 100% of the leaves. However, it wasn't a defoliating level because there wasn't a lot of inoculum out there early on. But powdery mildew is one of those that high humidity in particular can help push it along. So it is something to think about. But I agree, if you keep things cleaned up early on, then you can certainly it goes a long way for the rest of the season.
Okay. Can we? So we got a few minutes left here. I see this comment from Morgan Wilson. Any comment on massive yields outliers in the early years? For example, Connecticut Site 2 Frontenac 2012 at 21.5 pounds per vine. Michigan Frontenac Gris 2011 31.4 pounds per vine versus yield in 2013-15. Weather management or disease pest related? Well, I happen to know the one about the Michigan 3 site because that was one where Paolo Sabatini was intentionally trying to maximize the cropping on that, and he did the same thing with, I believe, one of the Marquette blocks on MI1, and that was an attempt to really push the vines past what a grower would normally do. I don't know the thing with the Connecticut Site 2 Frontenac, what happened there, but I don't think that 21 pounds is a huge, huge outlier for mature vines. If you look down to our Champlain vines, again, we got 15 to 20 pounds on a regular basis there, and Michigan Site 2 there, Frontenac, 15 to 20 pounds. So I think those that level is achievable in good sites. So I hope that answers your question. Unfortunately, I just don't know what all the outliers mean, and I haven't worked on trying to eliminate them. Okay.
Yes, thanks, Tim. So we have probably time for one or two more questions. Are there any particular questions that stand out to you, Tim?
Well, the next one by Bob Faden, and it sounds like you're from Montana, Bob. So I read recently that unlike the Frontenac, Marquette doesn't stay in dormancy very well if fall temperatures increase. Is this possibly a trend in La Crescent as well? They've had much more winter injury for us in southeast Montana than the Frontenacs. Well, I do have a comment about that because certainly what we've seen with both Marquette and La Crescent up in our site up at Clayton is that they seem to be much more susceptible to trunk injury and crown gall in certain respects than Frontenac. We had a year where we had, I think it was 2014, where in the Frontenacs, they came through with very unfruitful buds. All the primary and secondary buds were killed on Frontenac, but nothing happened to the trunks. So I think what you might be looking at there is a higher propensity to trunk injury. So in other words, on the Frontenac in that year, we had no crop, but very good trunks. On the Marquette, we had a very good crop. The buds were fruitful in that year, the secondary buds that came out after winter injury, but the trunks had a lot of trunk injury in them. So I think that's a case of maybe the Marquette and the La Crescent are more sensitive to trunk injury.
Okay, and I think time for just one more quick question. Mike White has a comment. I also wonder how much canopy management, hedging, or thinning during the prior season affects the next spring's pruning weight. Could it be that some of these pruning weights may have been put off?
I don't know the answer to that question, Mike. Yeah, I don't know. And this is always a problem with our vinifera trials too. Well, what if you hedge and you cut off a lot of foliage in the summer? What does the pruning weight actually mean? Is that still a good measurement? So I really don't know the answer to that. I'm sorry.
Okay, well, we're just about out of time. I'd like to thank Tim Martinson for his presentation, as well as all the panelists for commenting today. And thank you again to all our participants for your excellent questions. As a reminder, the webinar series will continue on Tuesdays of each month through May. Be sure to visit our Facebook page and feel free to email me or Tim any additional questions relating to today's webinar if you have them. The next webinar is scheduled for Tuesday, March 14th, and it will be on the impact of training systems on viticulture performance of cold hardy wine grapes with Amaya Atucha and Paolo Sabatini. The seminar will present research results from a trial in southern Wisconsin on the effect of 3 different training systems on the performance of 4 different cold hardy grape cultivars. Slides and a recording from today's webinar will be posted on the Northern Grapes Project website in the next few days. So thank you again, Tim, and to the project team leaders, and thanks again to all the participants from today's webinar.
Okay, I'd like to thank everybody too, and then in the questions that we didn't get to, I think I might try and respond to those later on and post the responses at our Facebook page. So Northern Grapes Project Facebook. So I'll try and respond to the remaining questions there via Facebook.
Great, thank you, Tim. I'll copy paste those for you.
Okay, well, thanks everybody for your attention, and I'll be back at 7 for another iteration for hopefully a big audience as well. Bye-bye.